Welcome back to the next session of Rehabilitation and Retrofitting of Structures course. In the last session, we were discussing regarding the retrofitting of columns, or I can say jacketing techniques. So in the retrofitting of structural member, I have been discussed the first technique, that is jacketing technique. So preferably this jacketing will be done for column jacketing or column structural member, so that we have been discussed in the last class. So now we will move on to the next one. So this is the one more way of strengthening the RC slab after deflection using overlay method. That means this is the one more method they have been using in order to strengthen the slab. In the last session I have been explained the strengthening of column by jacketing. Now they have been used one more method to strengthen the slab, that is overlay method. So let us know what exactly that overlay method one by one. So let us play that video. Okay, so first see, this is what the slab that has been deflected, and you can see the flexural cracks that has been formed. Okay, for this let us install the lifting system. That means, okay, this whatever the slab that has been deflected, and showing the flexural cracks, so that I need to be lifted that slab. I need to lift that slab and I need to go with the removal of these cracks. See, they have been provided the props, and this is what the hydraulic jack. So using this hydraulic jack and this I section, they have been lifting, okay, this slab, and they have been providing this, okay, whatever the crack that has been formed on the top surface also, okay, they are going to put a grout, that is a cement grout. So that is what injection of cracks. Okay, so this is what, okay, they have been going to inject the epoxy grout or cement grout. So based upon the chemical, okay, you are going to fill or heal those cracks. So these are, okay, they are also going to show the shear cracks, flexural cracks, all those things apart from the deflected shape. Okay, and see, you can see here yesterday what I have been told, or in the last session. So light hacking they have been done in order to create a bonding. So they are creating a hacking that is called light chipping. Okay, in order to create a bonding between the new concrete and a old concrete surface, they are going to chip the concrete surface. See here, okay, from this end to this end, okay, they have been chipped. Going with the next step, drilling the holes of a new double bars. Okay, so they have been drilling just like in the jacketing technique, how we have been drilled for a double bars for a column. Just like that we are going to drill the new double bars for the slab also. And later on, as I stated, okay, they are going to clean the drill, okay, drill hole. So we need to clean the drill hole. So it is a very, very important step, because that those loose whatever the paste or mortar that has been formed will not create a good bonding. So hence I need to remove those loose mortar from the drilled hole. So they have been removing that drilled hole or cleaning that hole. So this is the next step. Okay, so this is a complete hydraulic jack system or props. Okay, they have been provided. Next, they are going to fill up these holes with epoxy material. Once again, just what we did for a column jacketing, same like that. Why? Because we need to anchor this double bars. So this is the chemical way of anchoring. It is a chemical way of anchoring the double bars. You can see here how they are going to anchor the double bars. Okay, and they have been placed the reinforcement, newly placed main reinforcement, and also you can see the dotted one. The dotted one is called the transverse reinforcement. Okay, and later on they are going to put the bonding material, okay, in order to create a bond. Okay, so this bonding material, why they are going to put on the surface of an existing slab, Because in order to create a bond between the old concrete and a new concrete, they are putting a bond. So later on, they are going to put this grouting, okay, that cement grout, okay, on this, and later on they are going to, okay, cure it for 14 days, and you can see they are removing the prop and all those things. Okay, and this method not needed to design and expert staff to control the lifting and other process. So like this is the way, okay, this is the way how they are going to cast the, or what I can say, do the retrofitting of slabs. This is what the way how they are going to do the retrofitting of slabs. Okay, so in yesterday class we have been learned the column jacketing, and the today in this today class I have been showcased a slab overlay method, is slab lifting. So this is a common problem you are going to observe on the slabs, because of the variations in the live load, the slab will undergo deflection. Because of that deflection, it will show the flexural cracks and shear cracks. So the two things you need to take care here, one is lifting the slab, that is deflected slab will be lifted, and another thing is we need to heal that flexural or shear cracks. Okay, for that, okay, what they are going to provide the hydraulic jack prop system which have been showcased, and later on they are going to lift it, okay, and later on they are going to make a hole, okay, and they are going to fill up those grout, okay, drill the hole, okay, and also they are going to provide the additional reinforcement. Why they have been provide additional reinforcement? To take care of extra load that is coming on the slab. Because of that extra load, okay, that beam is undergoing deflection. Okay, so we need to take care of that. So in order to take care of that, they are providing additional main reinforcement and a dotted transverse reinforcement on above that. Okay, and they are going to cast it, okay, and cure it for 14 days, and later on they are going to remove that hydraulic props. So by this they are going to retrofit the slab, okay, by a overlay method. Okay, is it clear? So we'll move on to the next method, that is called external bonding technique. In yesterday class we have been learned jacketing technique, and also have been showcased overlay method. Okay, next we will move on to the external bonding technique. What is that external bonding? As the name itself indicate, I am going to provide some additional, that means some whatever the material on the as a bonding material externally to the concrete member. I will repeat, a material which is going to be provided externally by bonding, okay, is called external bonding technique. So this is the one more way of providing or retrofitting the structural members or strengthening the structural member. Let us see what is that. Suitable laminae or plates, steel plates, FRP plates, okay, or FRP sheets. Okay, so these laminates are pasted externally. So in the yesterday photo, I think in yesterday class I have been, in the last session I have been showcased, okay, how they are going to stick this L angle plates. Okay, so this is the one of the example for external bonding technique. So this is the one of the example for external bonding technique. So this L section plates, they are going to stick to the four corners, and later on this additional transverse plate, they are going to be welded and they are going to stick to the existing column member. That is what called external bonding technique. Okay, so that is why they are going to provide, okay, and this will be provided purely on the flexural zone. Very, very important. As we know, okay, if this is a beam, okay, if this beam is subjected to enormous loads, okay, it will undergo the flexural cracks or flexural shear cracks, okay, at the midspan. So this flexural zone I need to improve. This flexural zone or flexural cracks I need to improve or by strengthen by providing the external, okay, by providing the external bonding. Okay, so this external bonding or plate or technique which I am going to provide at the flexural zone, okay, in order to strengthen this beam or whatever the column or a slab. So that is what called external bonding technique. Okay. Next, and deformation characteristics. That what? So the deflection, flexure, so which have been showcased in the previous video, that is slab lifting by overlay method. There also have been improved the slab by it has undergo certain deflection that has been improved, and one more thing, it has been flexural, okay, the strength of a flexural member also been improved. Okay. Next, the laminates. What are those laminates? The laminate may be fabricated. It is very, very important. So it is a very important point you need to remember. Whatever the column jacketing, whatever the external bonding technique, whatever the slab overlay method, till now I have been discussing. Okay, if you going with this, for example, fixing the double bar, providing the external reinforcement, it is main reinforcement, transverse reinforcement, or example, if you want to provide these L plates at the corner and transverse reinforcement at the this, all these things need to be designed. Okay, we need to be designed and checked. Okay, then only I can go ahead or suggest these plates or mild steel reinforcements. Okay, without having a proper knowledge of retrofitting or designing these laminates or plates or reinforcement, you cannot accommodate simply. You need to design the retrofitting, okay, or whatever the retrofitting you have been suggesting to the strengthening of structural concrete member, you need to design just like what we are designing for a column beam slab member. Okay, for additional reinforcement or whatever the strengthening method you are suggesting, so those strengthening method extra you are suggesting, you need to design that. Okay, without designing, that's what. If you are going to design, okay, then only you can do the or give a proper fabrication. So then only the fabricator, based upon your design, okay, whatever the drawing you have been suggested, so that particular site engineer or a retrofitting who is person executing will clearly understood, okay, and he is going to execute. Is it clear? So that's what, fabricated properly in any, that is you can provide steel laminate, stainless steel, okay, you can provide FRP, that is next thing I am going to discuss, fiber reinforced polymer, Ferro cement, okay, it is a Sifcon, this is the product name, okay, Sulfur infiltrated concrete, so okay, it is a product name, okay, it is a branded product name, Simcon, Sifcon. So these are all the laminates I am going to provide, okay, the various material. The laminates are bonded to the distressed structural elements using epoxy, that's what I have been told. If I want to bond these L section plates at the corner or at transverse plates to the existing column, I am going to use a epoxy resin. The epoxy resin will act like a glue. It will act like a glue. Next, the design criteria suggested by researchers works in the plate bending techniques. So here, preferably external bonding technique, they are going to provide steel plates. Majority they are going to provide the steel plates. The plates or lamina whose width to thickness ratio should not be more than 50. Is a very, very important point. Whatever the plate you are going to design in order to stick externally by bonding to the existing structural member, okay, that width to thickness ratio should not be more than 50. Next, the central axis depth should not be greater than 0.4 times the effective depth of the member. So this is the one more point. So while designing, so these criteria, design criteria, we need to consider. While suggesting the steel plates or plates as an external bonding technique. So strengthening with external bonding of plates has the following limitations. It has certain limitations. Those limitations are difficulty in manipulating the plates. In field condition. Okay. So if I am that is what exactly the sentence says here is, for example, you have been designed and given to the fabricator. The fabricator prepares that, okay, and you will come to the site and you will do the entire process. Now, at any circumstances, if you want to change the design, you cannot do that. You cannot do that. Okay, because it is a customized, okay, the plate, okay, that will be fixed only to that particular column in order to strengthen that. If you are going to change the design criteria at the end stage, okay, it cannot be done so easily. So that is the first limitation. Next, deterioration of bent steel concrete interface. So there is a chance of this, whatever the steel plate, that is going to get deteriorated because it will be exposed to the external environment. If you are not going to cover with a concrete, there is a chance of getting deteriorated, especially by corrosion. Next, lack of proper formation of joints. So if the joints are not properly given, okay, then that means in between the steel plate joints is not proper, then there is a chance of, okay, cracks. Okay, so these are the limitations, okay, that is going to come across by external bonding of plates. Next, externally bonded, okay, mild steel plates. So this is the commonly used method. So let us know what is that. The technique of gluing mild steel plate to the soffit of the reinforced. So this is what soffit means, bottom. To the bottom of a reinforced concrete beam or a slab, I am going to glue the mild steel plate, okay, using epoxy resin. So epoxy resin will act like a glue and can apply to improve the structural performance, that is flexural wise, okay, shear wise, all those things. It increases the strength and rigidity and also reduces the flexural crack width. So that's what I have been told, okay, and also showcased in the slab overlay method. You can improve the structurally, you can improve the rigidity wise, strength wise, and also you can improve by, or you can reduce the flexural crack widths. That is what, this is the crack widths. The technique can be used to enhance the load carrying capacity either due to increase in load requirements or design or construction deficiency. So whatever the design or construction deficiency that has been come across in the structural member, that can be overcome by this external bonding technique. The technique has many advantages when applied to the bridges. So preferably this external bonding technique will be more suitable for bridges. The plates can be easily handled and placed, this allowing the procedure to be carried out relatively quickly with minimal disruption to traffic. That means you need not to, okay, worry about the, for example, if you are allowing for a traffic to the bridges, okay, in the bridges, especially in the bridges, okay, if you no need to worry about heavy machineries or something. It is a simple mechanism. The fabricator will, okay, fabricate those mild steel plates, okay, it will bring to the site and you will stick to the particular place. No need to worry about the traffics. So you can finish off the job very easily. However, this technique is not recommended for application of the bridge to with uniform concrete or those affected by corrosion unless the source of problem is rectified. So that's what I have been told. If you are going to stick the mild steel plate or whatever the steel plates externally to the member, there is a chance of getting corroded because those mild steel plate will be exposed to them, especially in the seawater condition. If you are going to suggest this technique, it is very tough to, I can say, do the retrofitting. That means whatever the retrofitting you have been done by this particular method, okay, there is a chance of getting corroded very early. Okay, so you need to take a proper precaution. Okay, you need to protect, that means you need to cover that steel plates. So those things you need to be done. Okay. So this is what the plate, what I have been told. See this is, please observe here, very important thing. See, they have been provided the bottom steel plates. They have been provided the bottom steel plate in order to increase the flexural capacity of the member. And this is the vertical steel plate they have been provided both to the slab and also to the beam, okay, in order to increase the flexural capacity and also the shear capacity, that is what, strength and rigidity. Okay, and you can see this is the customized one. Okay, in this particular zone the flexural capacity is very less, hence what they have been made, to this particular zone only they have been provided the steel plate. Okay, you just observe here. In this particular photo, the entire, okay, the beam requires, that means throughout the length of the beam it is demanding the plate. But in this case, okay, only to the vertical face of this beam they have been provided. Okay, so you need to be very cautious while designing. Where exactly the flexural capacity of the structural member is less, based upon that you need to go with the steel plates. Next, so this is the one more way you can see how exactly. See here, this is, okay, in the previous photo, okay, they are not being chipped. Okay, directly they have been applied. Here you can see the entire beam, okay, is retrofitting. Okay, see in this particular photo, the whole, okay, the beam is not showing the very good performance in the case of structural performance or rigidity or whatever the strength. So what they have been done throughout the length, both in horizontal face and also in the vertical face, they have been provided the designed customized mild steel plates or steel plates. You can see here. Okay, okay, you can see horizontally, vertically, okay, horizontally. Okay, like this they have been provided the steel plates. So in the one more photo, okay, they have been provided just like a column jacketing techniques. So like this, they are going to provide the external bonding techniques. So one more thing, okay, this bonded steel elements. The strengthening concrete member by using bonded steel plates was developed in 1960. That's what, the same thing. It was developed in 1960. With this method, steel elements are glued to the concrete surface by two component epoxy adhesive. That's what I have been explained. Same thing I am repeating here. Okay, epoxy adhesive to create or improve the structural shear and flexural capacity. The steel elements can be steel plates, channels, angles or built up anything. It may be plate. I also show the plates, channels. It may be C plates, angles. Okay, which have been showcased. So this is what angles. So this is what angles. So this is angles and this is plates. Okay. So in any ways you can provide the steel elements. In addition to this, epoxy adhesive mechanical anchors typically are used to ensure that steel element will share external loads in case of adhesive failure. So if there is any chance of failure, okay, so additional epoxy you can provide in order to take care of that. Okay, so this is regarding this. Next, so that is the method that is going to be provided externally by mild steel plate. Nowadays, advanced technique has came into picture. The advanced technique externally done with a material in order to increase the flexural shear capacity in the beam or a slab or in the column is strengthening with FRP composites, that is fiber reinforced polymer composites. Okay, what is fiber reinforced polymer? That means to the polymer matrix, the fibers are distributed. Okay, it may be oriented in any direction. Okay, those fibers, it may be carbon fibers, preferably nowadays they are using carbon fibers, it may be glass fibers, it may be steel fibers. So those fibers they are going to orient inside the polymer matrix. Okay, and those epoxy and the polymer, that is fibers, okay, will be impregnated. Okay, will be impregnated, okay, just like a mat. Okay, just like a mat. So those prepared mat will be called as FRP composites. So composite means a dual material, that is it is a combination of reinforcement and that is fiber and polymer matrix. That is what FRP composites. Is it clear? Fine. Next, fiber reinforced polymer. Let us see that. What is exactly that? Fiber reinforced polymer system are high strength. It is a very thin sheet which I am going to show you, and aesthetically also it is very good. I will show you the photo how exactly they are going to do. High strength, lightweight reinforcement in the form of paper thin fabric sheets. That's what. Paper thin fabric sheets. Okay, or certain thickness they are going to provide. Instead of providing jacketing, okay, chipping, all those things, okay, providing external bonding. Okay, instead of that we can go with this, a thin fabric. Okay, aesthetically also it is very good, and also compared to those two techniques, flexural capacity, shear capacity is also good. Or bar that are bonded to the concrete member with epoxy adhesive. Here also, in order to stick that FRP laminate, they are going to use the epoxy adhesive. These systems have been used extensively in the aerospace. Actually, this FRPs came into existence, okay, from aeronautical industries. In aeronautical industries, this material is predominantly or widely used. So, okay, from those, okay, the civil engineering has started to use this material, okay. So, automotive, sports, so in the sports, that means whatever the tennis rackets, okay, the tennis bats you are using, okay, so in those also they are using this FRP, okay. And also, maybe I think I have been told in the physical causes or chemical causes, and nowadays they are also manufacturing fiber reinforced polymer rods or reinforcement. So this FRP rods will be used as an alternative to the steel reinforcement. Please keep this in mind. Fiber reinforcement, okay, that is fiber reinforced polymer rod will be used as an alternative to the conventional steel reinforcement. Okay, so nowadays they are using this, okay. And this, okay, and now are becoming a technology for the structural upgrade of concrete. That's what. It is an upgrade. FRP is an upgrade version. And they are going to use various methods to manufacture this. I think in lower semester, you have been learned, okay, in alternative building materials, they are using a different technologies or construction methods to manufacture this FRP. They are going to use and layup technique, pultrusion technique, vacuum molding technique. Okay, various methods are there. Okay, filament winding techniques. Okay, in this vacuum molding or filament winding technique they are going to use and they are going to manufacture this FRP laminate. The important characteristics of FRP for structural repair and strengthening application includes non-corrosive properties, very good, because it is a demanded, needed, because we are facing the problem on externally bonded steel plate, especially in the zone of seawater condition. So that problem can be avoided with this. Speed and ease of installation, okay, very speed and ease of installation, lower cost, but cost wise I think it is not, acceptable, I can say. It is predominantly little bit higher compared to other thing. And aesthetically it is good. Aesthetically it is good. Okay, compared to the column jacketing, okay, as you've seen, and other thing that is externally bonded steel plate technique. So this particular method is comparatively good. Next, with any other external bonded system, the bond between FRP system and the existing concrete is critical and the surface preparation is very important. It is very easy to create a bond between reinforcement and the existing column. It is very easy to create a bond between the steel plate and the existing column, but it is very, very important and we need to be very cautious to create a bonding between FRP and a existing or a old concrete column, slab or a beam. We need to be very cautious. And also while designing the existing column, that means if you are going to design the strengthening of column, beam or slab with FRP, you need to be very cautious while designing also as a design engineer. See, this is what the thing they have been done. Okay, so this is the carbon fiber plates. Okay, instead of making as a thin fabric, they have been made as a plate. Okay, so they have been made as a carbon fiber plate. So this carbon fiber plate, okay, they have been provided at the soffit of the girder. To the soffit of the bridge girder, they have been provided in order to strengthen the capacity of a bridge. Okay, the same photo which have been showcased, okay, little bit with zoom, okay, with a higher magnification. See, this is what I wanted to show. See, here the person is applying a glue first. See, this beam is weak, okay, to take care, or I can say to hold the flex, that means the external loads, or I can say additional loads, and also the beam has reduced its capacity. The beam has reduced its capacity, okay, flexurally and both in shear wise, okay, because of the additional load. Okay, hence what they have been doing is they have been applying the epoxy to the, after applying this epoxy, okay, you can see here the black color one, this is just like a mat, okay, just like a mat. So this mat they are going to stick to the beam. They are going to just impregnate already applied to the epoxy resin or a glue. They are going to impregnate to the bottom or a soffit of the beam to improve the flexural capacity of a beam. To improve the flexural capacity of a beam. And the very important point you need to observe here is they are not going to apply the FRP mat throughout the length of the vertical face of the beam. It is a very, very important you need to observe here. Why? They are going to design, or the design engineer, they need to design what is the length of a FRP I need to provide. What is the thickness? What is the length of FRP? See, in this case, they have been provided just above the neutral axis. Just above the neutral axis to a certain distance they have been provided. That's what you need to design, to what extent, to what length or a width, okay, or thickness I need to apply or provide this FRP laminates. So this is a very, very important step I need to go ahead. A very important step I need to go ahead. Is it clear? Did you get my point? Because as an engineer we need to know why. Because so this is cost wise it is very costly. I think per square meter it may cost around thousands of rupees. For CFRP mat, I think it may be very costly. It is a very costly. Per square meter it is I think thousands of rupees. It may be 2,000 or 3,000 rupees per square meter. You just imagine if you are going to save the cost simply providing throughout the length of the or vertical face of the beam, if you cut down the length, you are going to save a cost. So that's what I have been showcased in the previous also. Where exactly it is flexurally weak, okay, in that particular zone you need to improve or increase the flexural capacity. So that is what there exactly the design engineer plays an important role. Is it clear? So as a retrofitting design engineer you need to know all these things. Okay, simply providing the laminate doesn't make any sense. We need to provide or we need to properly design or make a customized way, okay, to provide those FRP laminates. Okay, so this is regarding your FRP lamination. Next, we will move on to the next method, that is near surface mounted reinforcement. Near surface mounted reinforcement. So this is the next method of retrofitting of structural member. This is the next method of retrofitting of structural member. What is that? Let us see. The technique of near surface mounted reinforcement for strengthening concrete structure is currently being developed as an alternative to the externally bonded FRP or fiber composite material. Okay, so this is an improved version of FRP. This is an improved version of FRP. Okay, instead of providing FRP laminate, okay, we can go with this near surface mounted reinforcement. What is that? I will explain. The process involves cutting a shallow grooves in the existing concrete surface in the required direction. That means in the existing column or the column needs to be retrofitted. Okay, that column, slab or a beam, we need to groove to a required or a design depth. Okay, that is what the step. That is, the depth of the groove must obviously lesser than the cover so that the existing reinforcement is not damaged. This is a very, very important thing. Okay, so without damaging the cover, we need to excavate or we need to, not excavate, sorry, we need to make a groove. The grooves are partially, after making a groove, the grooves are partially filled with epoxy mortar into which the pultruded carbon FRP rods, that's what I have been told, this is the improved. So whatever the groove that has been made, so those FRP, that is carbon fiber reinforced pultruded, means by pultrusion technique they have been manufactured. That is what pultruded rods. Okay. So those rods will be inserted inside the groove already been made. Okay, and the gap between the groove and the pultruded rods will be filled with the epoxy resin. Okay, that is what the next step. Next, the remainder of the groove, that is the remaining space of the groove, is then filled with the epoxy mortar and the surface is leveled. Okay, and the surface is leveled. Okay, the remaining space, that means the top surface, okay, above the FRP rod will be filled completely with the epoxy mortar. Okay. This approach can be used to increase the flexural capacity, that is bending of beams and slab, or the shear capacity of the beam. It can also be used to strengthening the concrete masonry walls. Okay, if you want to strengthen your masonry walls laterally, because the masonry is very strong in carrying the compression load, but it is very weak in carrying the lateral loads. If you want to strengthen the masonry in the lateral direction, that means if you want to prevent the wind, that means a wind load, earthquake load, okay, in the masonry, we can go ahead with these techniques. Okay, as the fiber composite material is embedded in the concrete, it is less susceptible to damage. Okay, that is, for example, fire, vandalism, or whatever things. It is an advantage. It is obviously very appropriate for strengthening the top surface of the slab. So this is predominantly used for slabs. Where externally bonded fiber composites would require a protective layer, damage may be caused to the composite. That's what. If you're going to provide any external mild steel plate, instead of that external mild steel plate, or instead of providing external FRP plate, you can go with these techniques. So we can avoid those a problem, that is corrosion problem, damage problem, all those things. A further potential involved in this technique is use of externally bonded fiber composite is that no preparation of concrete surface is required. Here no preparation is required. Clearly one limitation on this technique is need to have a sufficient cover to the existing reinforcement. Okay, that means if you're going to make a groove, you should not disturb those groove. Okay, if you're going to disturb those groove, it may lead to the corrosion. So you need to be very careful to take care of that. Okay. So let us go. Okay, I will explain this, whatever the thing I have been explained. Okay, text. Okay, let us see one by figure, step wise. First steps. Grooves are cut after making a layout as per the engineer's, that is design engineer specification. Generally, the final groove dimension is 1.5 times the bar diameter in the depth and width. Okay, Dado cuts, this is called Dado cuts, are also effective if possible. Okay, see, okay, he's taking a concrete cutter. Okay, through the concrete cutter is making a groove. You can see here how exactly has been made a groove. Okay. The groove final dimension is 1.5 times the bar diameter. That's what they have been made. Next, step number 2. Chisel any remaining concrete between the cut. That means whatever the chiseling you have been made, if there is any exposed roughened concrete surface, chisel those and remove that in order to get a smooth concrete surface. Step number 3. Clean the groove and eliminate any residual dust with compressed air or vacuum. So that's it is a very important step, as I have stated. Okay, whatever the dirt that has been deposited inside the groove, those things you need to be removed. Okay, by a vacuum cleaner. Okay. Next, it is not necessary to roughen the interior of the groove with additional abrasion or brushing. That means don't use any brushing or something, steel brushes or something in order to remove that. Use vacuum. Okay, it will create that means concrete will get abraded. Okay, abrasion effect will be there. Step number 4. For a clean appearance, mask the concrete adjacent to the groove. See here, after grooving and removing the dust, okay, see here, they have been applying a red cellophane tape or something like that tape. Why? Because, okay, in order to mark, okay, to what depth and width you need to apply that. Okay, they have been marking. So initially they have been applied the tape, and later on, whatever the groove you have been made, okay, that groove you are going to cut along the length and width. Okay, you are going to cut that groove. Okay. So that is what the thing they have been made. Note, a time saving tip is to mask over that means you can save the time and you can apply accurately. Okay. Next, fill the groove approximately halfway with adhesive. Okay, half of the groove depth is filled with the epoxy adhesive. Okay. Step number 6, press the bar, that is fiber reinforced bar, which is going to be mounted inside the epoxy adhesive. That's what, partially filled with adhesive. The objective is to ensure adhesive is well consolidated around the bar without any air pockets. So without any air pockets, you completely fill that. Okay, next step number 7, completely fill the remaining space, that is above the FRP rods, with epoxy, mortar or adhesive, ensuring that bar is fully covered. That means it is fully covered inside the epoxy resin. Is it clear? Okay. Next, whatever the tape you have been applied in order to mark it. Okay, why have been marked? In order to apply those epoxy agent accurately. Okay, later on remove that marking tape. Okay, and this is the prepared near surface mounted reinforcement. And this technique, as I stated, preferably done for the external surface of a slab. That's why it is called exterior surface mounted reinforcement, or external surface mounted inside the epoxy bath reinforcement. Which is that reinforcement? FRP rods. So this is what a technique you are going to use. Is it clear? Is it clear? So hope you have been understood. Next, coming with one more technique. Okay, so hope that the concept has been clearly understood. That is, I have been discussed the column jacketing, we have been discussed overlay method, external bonding technique, external FRP technique, near surface mounted reinforcement technique. The next technique is external post tensioning technique. Okay, external post tensioning technique. Okay, first let me define what is post tensioning, because it is a new terminology you people have heard. Okay, and also this particular pre-stressed concrete structural member you are going to study in your for the next semester. Okay, so pre-stressed concrete structural member means it is an improved version of reinforced concrete structural member. Whatever the drawbacks are there in the reinforced concrete member, such as flexural capacity, okay, bonding capacity, okay, all those things can be enhanced or improved by using a pre-stressed concrete member. That means steel will be stressed initially, okay, and later on the concrete will be applied. So whatever the steel that is going to get stressed initially, that will be there throughout the service life of the concrete member. It should maintain that initial stress. And whatever the reinforcement you are going to use inside the pre-stressed concrete member will be called as tendons. Okay, that tendons will be designed. Okay, the tendons will be designed, and the capacity, the ductile capacity, the capacity of that tendon will be more than the conventional reinforcement. For example, the conventional reinforcement yield stress is 500 Newton per millimeter square is coming to the pre-stressed concrete member, whatever the reinforcement I am going to provide inside the PSC member, that yield stress will be 1500, 1200 Newton, almost double that of. Is it clear? Okay. Okay. So those steel will be provided or stressed initially in order to maintain or in order to get. Okay. So in those PSC member, you will be having two types. One is pre-tension and another one is post-tension. One is pre-tension and another one is post-tension. Pre-tension means stressing the steel initially and after applying the applying the concrete. It is called pre-tension. Post-tension means casting the concrete first by providing a certain space, that is called as what I can duct. Okay, inside that later on I am going to provide the reinforcement, that is called post-tensioning. Pre-tensioning and post-tensioning. Okay, is it clear? Okay, so now come to the concept. So now post-tension, that is external post-tensioning technique has been used effectively to increase the flexural and shear capacity both for reinforced and pre-stressed concrete member. That's what. Next, with this type of upgrading, active external forces are applied to the structural member using post-tension cables. That's what, cables, tendons. I hope you have seen the post-tension cable bridge. That's what the cable I am going to use here also. Because of the minimal additional weight of the repair system, this technique is effective and economical and has been employed with greater success to correct excessive deflection and cracking in beam and slabs, parking structures and cantilever member. So that's what it is a customized. This is also depending upon the structural members, you need to design the post-tension members properly, okay, and you need to accommodate those external post-tension techniques. The post-tensioning forces are delivered by means of standard pre-stressing tendon or high-strength steel rods. That's what, high-strength steel rods, okay, usually located outside the original section. I will show you that, okay. That high steel rods or cables, they are going to provide externally, okay, not internally, okay. The tendons are connected to the structures at anchor points, typically located at the ends of the member. So these are called the anchor points in order to anchor the design post-tension cables. End anchors can be made of steel fixtures bolted to the structural member or reinforced concrete blocks that are cast into place. That means whatever the anchors you are going to provide in order to anchor the cables, so those anchors will be fixed inside the concrete member firmly. So those are steel fixtures. The desired uplift force provided by the deviation blocks fastened at the high or low points of the structural elements. Prior to the external pre-stressing, all existing cracks are epoxy injected and spalls are patched to ensure that pre-stressing forces are distributed uniformly across the section of the member. Okay, so that means whatever the spalls or epoxy injection you have been done, okay, that means for example, if you want to apply this post-tensioning, before that initially we need to take steps, you need to heal the cracks, okay, whatever the spalling that has been happened, we need to remove all those things. An external post-tensioning system is used to strengthen pre-stressed double T's damaged by vehicular. So this is one of the structure which I am going to show you. 4 double T stems on an overpass located were damaged. This is a bridge when the driver of an override truck failed to observe the posted height restriction. Because of the height restriction, okay, he has damaged that girder part. Okay, you can see here, he has damaged that girder part. Okay, so this particular girder has been strengthened. See, this is what an anchor point. This is what an anchor and this is what a cable. You can see here. So this cable has been anchored with a proper design. Okay. So this is regarding your external post-stressing technique. You can see here, this is what I have been done. So this is a typical girder. Okay, to this T-beam girder, they have been provided the external post-tensioning techniques. Okay, so hope this concept has been understood. Next, coming to the one more retrofitting way. That means depending upon, that's what I have been told, depending upon the cracks or depending upon the strengthening technique. That means depending upon the disease, how the doctor suggests the medicines, depending upon the member, depending upon, because those diseases, okay, you are going to observe in the human beings is not common. It may vary. Like that here also, whatever the cracks or whatever the distress or whatever the damage you are going to see will not be same in all the structures. It may vary. Okay, so based upon the damage, based upon the distress, based upon the cracks, you need to apply the proper retrofitting techniques. Is it clear? Next, going with the section enlargement. Okay, the method of strengthening involves placing additional bonded reinforced concrete to existing concrete. As the name itself indicates, I am going to increase the sectional properties of the member. That is what called sectional enlargement. Why? because it is showing structurally weaker performance in flexure, shear, tension, all those things. So if you want to increase the capacity of that beam or a thing, okay, member, then we need to go ahead with a sectional enlargement. Okay, so that is what called. So how we are going to show you? With sectional enlargement, the column, beam, slab and walls can be enlarged to increase their load capacity or strength. That's what. Why? Okay, why it require a sectional enlargement? So this is the answer, to increase the load carrying capacity. A typical enlargement, okay, at what extent you can go with sectional enlargement? A typical enlargement is approximately 2 to 3 inches for slab. You can increase up to 2 to 3 inches and to 3 to 5 inches for beams and column. That depends now again, that depends upon okay, what loads you are subjecting and what, okay, that means for example, if you are going to increase the slab thickness, you need to concentrate on the beam and the column, because those slab load will be carried by a column. You need to take care of that. Simply increasing the slab load, that doesn't make any sense. If you're going to increase the slab load means you need to check whether the column can withstand those increased thickness of the slab. Okay, all those things you should keep in mind. Simply by increasing the slab thickness, that doesn't make any sense. You need to also take care of column also, because that column should bear the slab load. Okay. And 3 to 5 inches for beams and columns. Section enlargement used to increase the capacity of a main girder. The girder was, this is also preferably used in the bridge girders. The girder was re-evaluated because of change in required loading. Because the vehicular load may change, it will be subjected to variation in traffic loads, all those things. Found to be deficient in flexure and shear. So this is the deficiency. To correct the deficiency, additional flexural steel and shear steel. So whatever the deficiency shown by the girder, that is flexural capacity, shear capacity. So those flexural capacity and shear capacity will be improved by providing a reinforcement. The entire beam then was formed and a 4-inch jacket of concrete was cast to enlarge. This is a typical case study have been showcased. Okay, the girder having a problem. So those girder having a problem will be strengthened by 4-inch jacketing. Okay, let us see that. So this is what I think. Okay, you can see here, this is a slab, this is a beam. Okay, this is a T-beam, what I can say. So this is the existing member. Okay, you can see here, to this existing, a grey color one is called existing member. Okay, and this is the already provided reinforcement. So whatever the semi-solid portion you are seeing, it is an already provided reinforcement. So to this already provided reinforcement, what I am going to do here is, I am going to make a groove in the existing member. To this grooved member, I am going to provide this extra, okay, steel all around the periphery of the existing column. This is called as stirrups. Okay, it will be stirrups, and this will be designed, okay, main reinforcement that is going to be provided to increase the flexural capacity. So this will be provided to increase the shear capacity, that is called steel stirrups or post-tensioning strands. Post-tensioning strands. And these longitudinal steel bars will be provided to increase the flexural capacity. Is it clear? Okay, and later on you are going to fill this by a concrete. Okay, fill this by a concrete. So this is what called enlargement. So I have been enlarged from this end to this end. So this is the enlargement thickness I have been made. So this is called sectional enlargement. This is called sectional enlargement. Okay, so with this, okay, I have been discussed the various retrofitting techniques. That is, we have been discussed, if I want to summarize this retrofitting, I have been discussed retrofitting of structural members by jacketing techniques, retrofitting of slab, preferably slab, by overlay method, retrofitting of structural member by external steel plates, retrofitting of structural members externally by FRP laminates, retrofitting of structural members by external surface mounted FRP reinforcement. Next, retrofitting of structural members by external post-tensioning techniques. Next, sectional enlargement. So these are the various retrofitting of structural members I am going to suggest. So all these things I am going to suggest, okay, based upon the structural members and based upon the damage or distress, okay, and based upon the structural capacity, whether it is weak in flexure, whether it is weak in shear. So with all these conditions, as a design engineer, I need to look into that structural member before going with the design concepts or retrofitting of or strengthening of structural members. Is it clear? So this is the various methods have been discussed, okay, and for various concrete members or structural structural components, okay. Hope the concepts which have been clear, and if possible I am going to show you the strengthening videos, some more strengthening videos in the next class, so that you can understand the concepts very clearly. Okay, just like which have been showcased, like column jacketing video, slab overlay method, like that. So I also got some more strengthening videos which I am going to show you in the next class, okay, or next session. So hope these concepts have been cleared. So hope this concepts is very much useful and you will be practicing, okay, in your future endeavors. So with this I am going to thank you. So thank you for this session.